Periodicity in electronegativity. Periodicity, variation. Periodicity is variation in electronegativity. Periodicity in electronegativity. First number. In period. Along a period, electronegativity increases from left to right. Electronegativity increase from left to right. Electronegativity increases from left to right. As the size of atom decreases, and size of atom decreases. Elements electronegativity. Elements: lithium, barium, boron, carbon, nitrogen, oxygen, fluorine. Lithium, barium, boron, carbon, nitrogen, oxygen, fluorine. Lithium 1.0, barium 1.5, boron 2, carbon 2.5, nitrogen 3.0, oxygen 3.5, fluorine 4.0. This is due to the increase in nuclear charge. As a result of which the added electrons can be more strongly attracted by the nucleus. Second number. In group. In a group, electronegativity decreases. In group, electronegativity decreases. From top to bottom. As the size of the atom increases from top to bottom. Top to bottom. Element and chi. Lithium, sodium, potassium, rubidium, cesium, francium. Lithium 1.0, sodium 0.9, potassium 0.8, rubidium 0.8, cesium 0.7, francium 0.7. Hence, small atom attracted electrons more strongly. Than large ones. So they are more electronegativity. Thus, the most electronegativity elements fluorine is present at top right hand corner of the PT, while the most electropositive element cesium, has less electronegativity value is at the bottom left hand corner in PT. Electronegativity chi equal to ionization potential plus affinity, elements affinity upon 5.6. As both IP and EA increases, both IP and EA, as both IP and EA increases from left to right, if IP and EA increases from left to right in a period, hence chi also increases, hence chi also increases, and chi also increases from left to right in a period, since IP and EA decreases and IP and EA decreases, IP and EA decreases, IP and EA decreases, IP and EA decreases from top to bottom, from top to bottom, in a group. Chi also decreases, and moving down in a group. Okay, and next heading is application of electronegativity or influence of electronegativity on the chemical behavior of molecule, influence of electronegativity, influence of electronegativity, influence of electronegativity on chemical behavior, on the chemical behavior of molecules, are application of electronegativity. Application of electronegativity. Application of electronegativity. It has a very wide range of application. The importance of application are given. The first number is electronegativity and nature of bond. Electronegativity and nature of bond. Electronegativity and nature of bond. And nature of bond. According to pooling, the bond between two atoms is 50% ionic. According to pooling, the bond between two atoms is 15% ionic. According to pooling, if the difference in their values of electronegativity is equal to 1.7, if the difference is more than 1.7, if the difference is more than 1.7, the bond is more ionic. Bond is more ionic. If the difference is less than 1.7, if the difference is less than 1.7, the bond is more covalent in character. The bond in less than more, if the bond is more than 1.7, more ionic. If the difference is less than 1.7, the bond is more covalent in character. The bond is more covalent in the character, covalent in character. Example, nature of bond in AB molecule can be predicted as follow when A point A, when chi A minus chi B, minus chi B, or chi A equal to chi B, or chi A minus chi B equal to 0. AB bond is non-polar covalent. AB bond is non-polar covalent. Non-polar covalent. B point. Point B. Point B. When chi A minus chi B equal to 1.7. When chi A minus chi B equal to 1.7. 1.7. AB bond is 50% ionic and 50% covalent. Then AB bond is 50% ionic, and 50% covalent. 50% covalent. When C point, when chi A minus chi B is less than 1.7, then the ionic bond is less than 50%, and covalent bond is greater than 50%. Less than 50%, and covalent bond is greater than 50%. Covalent bond is greater than 50%. And D point. When chi A minus chi B, is greater than 1.7, ionic bond is more than ionic bond is more than 50%, and covalent bond is less than 50%. Second application is electronegativity and percentage ionic character. Second position, electronegativity and percentage ionic character. Electronegativity and percentage ionic character. And percentage ionic character. Electronegativity and percentage ionic character. Pooling rule does not valid in all cases. Valid in all cases. Haney and Smith have revised the pooling question. According to them, ionic character. Percentage ionic character equal to 100 in bracket 0.16 chi a minus chi b plus 0.035 in bracket chi a minus chi b chi a minus chi b whole square and the bracket is closed. Then the value is 16 chi a minus chi b plus 3.5 chi a minus chi b whole square, where chi a equal to electronegativity of atom A. Electronegativity of atom A and chi b equal to electronegativity of atom B. Electronegativity of atom B. Percentage character, percentage covalent character. Percentage character, percentage covalent character. Percentage character, percentage ionic character. Percentage covalent character. Percentage covalent character. This is HF, hydrogen fluoride, hydrogen chloride, hydrogen bromide, and hydrogen iodide. 43% of ionic character and 57% covalent character. In HCl, 17% ionic character and 83% covalent character. Hydrogen bromide, 13% ionic character and 87% covalent character. In hydrogen iodide, 7% ionic character and 93% covalent character. Third number, usage of third number using. Third number, electronegativity and stability of bond. Electronegativity and stability of bond. Greater the value of chi a minus chi b, greater is the stability of AB bond. Greater the value of chi a minus chi b, greater the value of chi a minus chi b, then greater the stability of bond AB. Then greater stability, greater the stability of bond AB, or AB bond. Heat of formation value also supports this fact. The compounds with a very small value chi a minus chi b are unstable and their heat of formation is also very small. And 1 minute. The compound with very small value of chi a minus chi b is if a value of chi a minus chi b is small, is small, is small, then the unstable, then unstable, then unstable, and their heat of formation is also very small, and their heat of formation, heat of formation, heat of formation, heat of formation is also very small, is also very small, very small. Compounds which chi A minus chi B value is greater are found by combination of metals and non-metals. This compound is very stable and have large value of heat of formation, high melting and boiling point, high melting and boiling point, high melting and boiling point. And next point is compounds which chi A minus chi B value is greater, chi A minus chi B value is greater are found by a combination of metals, greater are found by the combination of metals, and non-metals, metals and non-metals. This compound are very stable. These compounds are very stable and have large value of heat of information, and has large value and has a large value of heat of formations. Stability chi x minus chi h, and this is the heat formation. The values of HF bond. Which bond? HF bond is the greater than HCl bond, is the greater than HBr bond, is greater than hydrogen iodide bond. This the chi x minus chi h equal to 1.9, 0.9, 0.7, 0.4, and this value is minus 64.5, minus 22.0, minus 12.5, minus 1.5. And next fourth is metallic and non-metallic character of element. Fourth is metallic and non-metallic, metallic and non-metallic character of elements with lower value of electronegativity. Are metals, while of higher value are non-metals. Electronegativity Elements with lower value of electronegativity. If lower value of electronegativity are metals, and higher value of electronegativity. Higher value of electronegativity. Higher value of electronegativity are non-metals. Electronegativity are non-metals. As we know that chi value along a period increases from left to right and in a group decreases and moving down from top to bottom. Hence in a period metallic character decreases. Hence in a period metallic character decreases. Where is in a group metallic character, where is in a group metallic character from top to bottom decreases. Elements with lower value of electronegativity are metals, while of higher value of non-metals. As we know that chi value along a period increases. Then increases from left to right and in a group. As we know that chi value along a period increases from left to right and in a group decreases and moving down from down to hence. Hence in a period metallic character decreases. Whereas in a group metallic character increases. Example: carbon, nitrogen, oxygen, fluorine are non-metals, while Pb, bismuth, PO, AT are metals. And fifth application is acid base character of normal oxides in same period. Acid base character of the normal oxides in the same period. And moving from left to right in a period, acidic character of the normal oxides increases. In moving from left to right, moving from left to right, moving from left to right in a period, acidic character of the normal oxides increases. Acidic character increases. The change from strongly basic character to strongly acidic character is due to the increase in the electronegativity value of the elements chi and decreases in chi minus chi value. Oxide. And sixth number. Color of the salts. Percentage ionic character depends upon electronegativity value. There is a close relationship between the percentage ionic character and the color of the salt. A point. Point A. Point A. If the ionic character of the bond is less than 20%, if the ionic character of the bond is less than 20%, the compound is colored. The compound is colored. B point. If it is more than 20%, if it is more than 20%, compound is colorless. Compound is colorless. Compound is colorless. And C point. If it is very less than 20%, if it is very less than 20%, the color change through yellow and orange to red. The color change through yellow and orange to red and black. The color of silver halides and sulfides have been and compounds. This is as an example. We talking about example. Then the values compounds, percentage ionic character, and color. This is AgCl. What is AgCl? AgBr, AgI, and Ag2S. Ionic character: silver chloride 80% ionic character, and silver bromide 24% ionic character, and silver iodide 15% ionic character, and Ag as 4%. This is the colorless, white in color, white. This is light yellow. The color of Ag silver iodide is yellow color. What color? Yellow color. And the color is black. Seventh number is electronegativity and bond angle. Seventh number very important. Electronegativity and bond angle. The electronegativity value of central atom affects important effects on bond angle. Compound chi of central atom and bond angle. This is bond angle. Then the values are NS3 chi of central atom 3.0 and bond angle 107.3 degree. PH3 chi of central atom 2.1 and bond angle is 93.5 degree. And AsH3, the 2.0 chi of central atom and 91.8 degree bond angle. HB H3 1.9 and 91.3 degree. This is the bond angle and this is the chi of central atom. In case of NH3 and PH3, in case of in case of NH3 and PH3, sp3 hybridization takes place. Both contain one lone pair also, but bond angle differ from each other. This is explained as follow. The lower the electronegativity of the central atom in a polyatomic molecule, the lower the electronegativity of the central atom in a polyatomic molecule, the smaller will be the bond angle. If electronegativity of central atom is small, it could not attract the shared pair of electrons more strongly towards itself. Hence, bonding electron pairs would shift more towards the other atom joined to the central atom, due to which bond pair repulsion would be reduced, and hence there is a decrease